helpful, and I do think if you're using these videos that you can go back and watch them. But when I look at number 4, one of the things I know is this is my 1.5, right? And that is my y-intercept. And if I'm graphing mx plus b, and then the other thing I might want to be thinking about is I might want to draw that face and go, oh, positive slope is up, negative slope is down, zero slope, because you have zero slope, right? You have a zero slope in number 6 in this first equation of number 6, right? And we have positive and negative slopes when we are looking at number 4. So when I start off, the first thing I'm going to do is look at my constraint. As I look at that constraint, that's where I kind of want to draw a dashed line. So I look at the constraint is at x equals 1. So at x equals 1, this is where my 2 lines have to start changing, right? So that is my definite place I need. So when I look at this one, it's at 2. When I look at number 5, and 6 has three different lines, or 2 different lines that you're looking at. I want to plot at 1.5. 1.5 is right here. That is my y-intercept. So this is my start, my 0b. So those of you that struggled on that last quiz, where's the y-intercept? That's the first thing. The m is how you are moving, and that's always my rise over run. So from this point at 1.5, I'm going to graph this first one in red. I'm going to go up 1 because it's a positive slope, up 1 and over 2. Now, I don't really want to keep going this way because that is above that line, and I'm talking about everything below it. So I'm going to go down 1 and back 2, down 1 and back 2. And I'm going to draw this line, and I'm not going to go from the y-intercept. I'm going kind of right from this point. So I'm looking at this line, and I definitely want an arrow on this side. And I'm going to erase everything that was above here. And right now, that's an open circle because it was less than 1. So I have to go past my y-intercept at 1.5, which looks like it's up at 2. Did yours look at 2? If I was looking at this point, this is over at 1, 2. Is that where yours is about, the turning point? If I plug in 1, 2 into this equation, and I plug in 2 for the f of x, is it true that 1/2 times 1 plus 1.5 equals 2? So that's a checkpoint. So when we talk about how you can check these all the time if you're doing it right, I'm looking at the second equation. So let's change our color. We're going to do this one in blue. Y-intercept is 3. I am not going to have this part of the graph drawn because it has to be everything only from this side where x is greater or equal to 1. But I'm going to start with my y-intercept, and it's a negative slope, which meant it went down. So I go from this point down 1 and over 1. Oh, it ends up at 1, 2 also. Down 1 and over 1. Down 1 and over 1. And I am only graphing that part. So I do each of those sections individually. Number 5 is very similar to that. So your start point is back here. This is where you should start your graph. And then your movement, this one is a negative 2 over 1. This one is a negative 1 over 1. So you should take a look at those and try those. I agree that number 6, if you are looking at that, there was a lot more of you that had questions on that. When I look at number 6, this is my first boundary line at negative 2. My other boundary is up at positive 2. Putting those in just helps me to define where my graph is. So I look at the first equation, and the first equation is really asking me to graph y equals negative 4. That's what this part says. It says this. Well, there's no x. So it says 0x. That meant my line is horizontal. Where? Where y equals negative 4. So I have to go down to the negative 4. I had some of you going over here to negative 4. That's your x. You're looking at the y down to negative 4. And I would have drawn this whole horizontal line. But I'm only going from less or equal to negative 2. So I go to the second part. The second part says, oh, your y-intercept is at negative 2. So if I'm going to that second one, this is graphing y equals 1x minus 2. So I go to negative 2, my y-intercept. So I'm not sure where that is. You need to be really close on knowing and understanding those three different forms of equations. And so you go to -2, and now the slope is up 1 and over 1. So I'm going to have this point and this point. I'm not going to go any further than that, right? This is an open circle here. Why? Because it's less than 2. And now I'm going to go down 1, and oh, this is a closed circle. So I'm going to have this line in between those 2 points. Now I go to the last one. My last one says we are starting at y-intercept of what? Tell me, what's my y-intercept in the last one? Up to +4. Slope is -2 over 1. That means it's a negative going down. I think about my face. Negative slope. Down 2 over 1. Down 2. Oh my gosh, well, that was open before it went to that same point. And I'm going to keep going. Down 2 and over 1. And down 2 and over 1. But I'm not going to graph this part of it up here. I'm only graphing from here. And that is my solution. And so when you are doing those questions, 25 says, I'm going to be able to explain, so if I'm looking at my I can statements, explain the function, what it looks like for absolute value. We're going to be looking at this as a piecewise function. So it's kind of a continuation of yesterday with piecewise. We're going to talk about the key features today and tomorrow. We do absolute value today and tomorrow. And we are going to graph these using evaluated points. So when we are looking at those. And we're going to make predictions. So first off, your definition. Absolute value, key thing that we know from earlier this year, is the distance from 0. So absolute value of 5 is 5. As is if I would find the absolute value of -5. Both absolute value of 5 equals 5, and if I'm looking at how far -5 is from 0, it equals 5. So I have sometimes people thinking absolute value means opposite. It does not. It means the distance from 0. And distance is always positive or 0. It's never going to be negative. So the absolute value of -4 is how far is that from 0. That's our basic definition that we want to think about. So here is our piecewise function. We want to make a table and draw a graph for the equation. It says these two things are the same. If I would have asked you to graph y equals x for x greater or equal to 0, here's my boundary line, right? Going down. It's that vertical line when x is 0. That's what this constraint is telling us. So put that dashed line where I just did. And if you need to put it above, just so that you can see that. It's on my y-axis. That's where my constraint is. They're telling us to graph y equals x. What's the y-intercept? 0. Oh, what's the slope? 1. Up 1 over 1. So let's draw that line. Now when you come in with this unit, if you want, there's rulers up in front. And for making nice straight lines, or unless you're using like the edge of something else. So this is that first line, right? You agree? We're going to put an arrow on it. So this is y is equal to x. How about this side? So our slope, still y-intercept is 0, right? But this time we are looking at going with a negative slope. Negative slope, and if it helps you, to put the face with the positive and the negative and the 0 and the undefined, draw the face if that helps you as you're looking at your slope. That one's kind of small up there. So if we are going to draw this line, question?
If
Go.
it's like the second one, since it's negative, how do you do the closed or the open circle and the closed circle at the same point?
Good question. How do we do the open and closed circle at the same point? Since one of them is actually closed, you're just going to keep it closed. And if you plug into 0 in either equation, if x is 0, y is 0, negative, they both come out the same. So if it's on that same one, you're usually going to go with the filled in circle instead of open. Okay? So if I was looking at this table, if I plug in the value of x is -2, when x is -2, what do we get? 2. If I plug in -1, I get 1. If I plug in 0, how about 1? 1. And if I plug in 2, I get 2. So we probably use, for most of you, are telling me right from these points on the graph, right? But if you would have looked at just this equation, you would have said y is equal to, that's this is my y, is equal to the absolute value of -2. And isn't the absolute value of -2 equal to 2 that we just talked about? And if I take a look at the absolute value of -1, it equals 1. And if I take the absolute value down here of 1, y equals the absolute value of 1, that equals 1, which is what we got for our y value here. So it says this is a parent function for the absolute value. If we were going to describe the shape, so what would you tell me is the shape of this graph? Is it linear? The second question?
No.
It is definitely not linear, right? But what would you tell me is the shape of that graph? What shape is this? What letter do you see?
V.
It's a V shape, right? So we have a V-shaped graph. Anytime you were going to work with absolute value functions, all of our absolute values. If you remember that from like the first or second test, that first test when we graphed absolute value, it kind of came out as a V for some of you. So when I look at it, it's a V-shaped graph. And the other thing that we were going to be looking at is that our vertex is at the origin. And the origin is located at 0, 0, right? Other key features, it opens upwards. Because we're going to have some of our V functions are going to open downwards. So make sure you're writing all this down. And that second question, is it linear? Not linear. Linear means it has to be a straight line. It is made up of 2 linear rays. So it is made up of 2 linear rays, right? So this is one ray going up with a positive 1 slope. This one has a negative 1 slope. If I asked you for the domain of this function, because that's going to keep coming up in this unit, what's our domain for this function? Can we put in any x value? Could I put in a half? If I put in a half, I should get 1/2. If I put in a -1/2, I get, if I put in -3.75, can I put that in?
Yeah.
So our domain, our x values, all real numbers, right? What's our range? Where y is greater or equal to 0 for this one, right? It doesn't go below this 0, right? Y values, there's no -1, there's no y is for my real values, okay? That's going to keep coming up as we look at these, okay? As you look at the top of that next page, it says we want to write, this is a piecewise function, okay? You take a look at this. So we want to start with the left part of the graph, and we want to write the equation, okay? So if we are looking at this, first thing we might want to identify is where is our constraint, right? Our constraint is at, if we are looking at this, x is, and it looks like it's less or equal to 1, right? So we're going to go x is less or equal to 1. If you were looking at the function, what's our y-intercept? What's our y-intercept? 0 for this one, right? So, and our slope is -1. So -1x plus 0. Could someone have just written y equals -x? Okay, so I take either one of those 2 answers, right? This is the same thing, right? Just so we're aware of that. Y equals -x. So that's the left side. Now we're going to do, so now we want to look at the right side. The right side is going to be where x is, and we really can't tell because this is a closed circle if we should go greater or equal. So we're going to put greater or equal because we're not sure which one. And since one of them is closed, you could have one being equal and one being just greater. It wouldn't matter, okay? And as you look at this, what's our y-intercept for this line? Careful.
1.
-2. This line, right? We're looking at this right line. If we extend that down, we go with y equals, what's our slope? Up 1 over 1 up. So y equals 1x minus 2. So this is what you were doing today in your homework. If we were writing that piecewise function, we'd say f of x equals. The first function was negative x when x is less or equal to 1. And the second piecewise of this function is y equals x minus 2 if x is greater than 1. And if we are looking at that one, it now asks you this question. Why is this the same? Why is this the same as the absolute value function y equals x minus 1 minus 1? I want you to keep in mind, someone want to tell me how to write point slope form of an equation? Y equals what? How many? So if you look at this equation, and you look at this one, make sure you write this one down. What would you tell me the point is? What would you have told me my point? If this would have been a parenthesis, you would have told me that the slope of this one was 1, right? If this would have been a parenthesis instead of absolute value, what would you tell me the point is? Would it be negative 1 or 1?
Positive 1.
Positive 1, because this is a minus, right? And that's a minus, so it'd be positive 1. What would the y coordinate be? Negative 1. Look at where this point is. 1, negative 1. What's the slope of this line? 1. What's the slope of this line? Negative 1. So, it says, why are these the same? I want you to take a look. If we take this first piecewise function, so I want you to write y, we're going to write this function right here, right? If we were going to solve this, what does the absolute value of x minus 1 look like? It looks like x minus 1, and then we're going to subtract 1. Do you agree with that? If I was just going to write this, okay, this is going to be what's called my positive case, and I just want you to see that, okay? So if I rewrite that, does that make sense that this was the positive? Simplify it. What do you end up with? Y equals x minus 2. Wasn't that the same up here as we had? Right? Okay, so now we're going to look at over here. Please write the negative case. This is going to be our negative case. When you find absolute value, remember when we started off and we said, oh, if y is equal to the absolute value, there's a positive and negative. So we're going to put a negative out in front. This is my negative case. And you're going to put x minus 1. And then we're going to keep this minus 1 back here, right? So this minus 1 that we put, this minus 1 is the same as this minus 1 here. Same thing here, right? I just kept that part. I'm going to take the positive case, that was x minus 1, this is the negative. This means we have to distribute this if we want to simplify. When I distribute negative 1, I get a negative x plus 1 minus 1. Simplify it one step more and we'd end up with y is equal to negative x. That's what we had up here. This is the one we had down here. So when we look at those positive and negative cases, okay, this going back to that point slope form is really going to help you when we do finding our equations. But that's going to be more tomorrow, okay? So the next page down says we want to use translations and graph. A translation is simply a shift horizontally or vertically. Sometimes it's going to be both. The result is that the graph is the same size and shape. So we're going to keep getting these v's. And notice if I look at all of these, what number is out in front of that absolute value? 1. So what do I know my slopes of all my lines are? Positive 1 and negative 1. And sometimes we write it this way, plus and negative 1. So put that below each one. And if you look at your graphs, do each of them have a positive and negative 1 slope? Every single one of them does, okay? So can we quickly graph absolute value function by translating it? This is called my parent function. Notice this one, what did they do? When it was minus 2, it went down 2. If you think of where that point slope form of our equation, right? X minus x1 plus y1, what would the x1 have been in here? 0. And this would be 0, negative 2, right? There's no number inside there. What would this one be? 0, 0, 1. Point slope form of that equation is how we're always going to kind of be looking at these. And what this plus 1 does, it says compare these graphs as we are looking at them. And I think it's easier for you to look at this, what they have written, than me writing it out, because writing sometimes when I have to write a lot, it's not as great as I'd like it to be. And I always go back to cursive, and students can't always read my cursive writing. So, this is what I want you to write down. If you add a number, and here's what I would put. Don't put that whole thing. I want you to put, if you add a number, don't put to the right side. Say outside the absolute value. So, if you add a number outside the absolute value bars, the V shape moves up that many units. So because I have a plus 1, I take that V shape and I just move it up 1. If it would have been a plus 5, I would have moved it up 5. Same V shape, okay? What I want you to write for that next part is if you subtract a number or add a negative number outside the absolute value bars, the V-shaped graph moves down that many units. This one moved down to 0, -2. So when you are looking at that, my point slope form of the equation, y equals m, x minus x1 plus y. We're using this a huge amount as we finish this with absolute value. So, our first one, what did we know our slopes were? Positive and negative 1. Where's our vertex? That means this point. The vertex is at 0, 0, right? That's my vertex, okay? So when we look at these, we're always going to be looking at where the vertex is going to be moving, and we're always going to be looking at the slopes, and then we're going to look at the domains and ranges. So when I look at this one, where's my new vertex if I'm looking at that, Emma? Where's my new vertex? Where is this point? I know this is a 3 here, but what's my new vertex point? Maybe 3, 0. Also could be called my x-intercept, right? If we are looking at that. This one only has one x-intercept, right? If we are looking at this one, why? What's my new vertex point? Positive 2, 0. Okay? And if we think about this form of the equation up here, what would the x-coordinate be? 2, and the y plus back here would be 0, 2, 0, right? If I look at this one, plus 3, oh, that would be minus a -3. This is the -3 plus what? 0, that's that point, right? And if I look at this one inside here, it would have been 0 and 0. That's why I got my vertex, right? So, did our slopes change here? Positive and -1. Did the slopes change here? Tomorrow the slopes start changing. Positive and -1. Okay. What changed? My vertex. My vertex of this one, if we wanted to write it, maybe you just want to write it over here. Our vertex is down at -3, 0. My vertex on this one is 2, 0. So when the number is inside and it's added, versus than the last time, right? Over here when we looked at it, when the number was outside and we added it, it moved it up. When it was outside and we subtracted it, moved it down. So what could we say this time? If we're adding inside, it moves it to the what? Left. If we subtract inside, it moves it to the right. And what you're really looking at is back to this equation. So, again, I know some of you like to copy every single word. If you add a number, I would just go with inside the absolute value. The V shape moves left. I think that other part to the right of the equation gets some of you messed up. I wouldn't write it. The second part, if you subtract a number inside the absolute value bars, it moves to the right. Those are the key things that you want to write down with that. I think when I was reading this that we've written, I think that for some of you is more confusing. I would just go with that first phrase, okay? And so what, as you finish writing this down, I want you now to predict where the vertex of this graph should be located. So just like we did our vertexes up here, As soon as you're done writing this, predict that next one. Going back to our point slope form, we just said if we add inside, it's moving it to the left. So the left of 0 would be where? -5. So I'm thinking that this is going to be -5 and 0, because there's nothing outside here, right? Could you have told me move to the left 5? Yes, but then make sure you give me the ordered pair also, -5, 0. Okay, so we're going to do some graphing on that last part down in your notes before you get started. So the first thing I want you to think about each of these is, where is your vertex? So we're going to write right below, where is our vertex for each one. So we're always going to have our vertex, it's always going to be an ordered pair. And if it helps you to write the point slope form of that equation, x minus x1, write it down, because it helps you to look at it. So first we're going to find the vertex. The next thing we're going to find is the slope of each one. The m or our slope. Then we're going to talk about the domain of each one and the range. So we're always going to have the vertex, the slope, the domain, and the range. Do we want to do the first one together, or you want to try it on your own? First one together. So I look at this, -1, because it's a -1. I think back here, that means my x-coordinate is +1. This is a -3 back here, which is telling me it's going to be moving down. And if I look at that, it should be 1, -3. Does it make sense that we move to the right? We said if we subtract, we're going to move to the right. So we go to 1 and down to -3. At this point, we are now going to have a slope of what? What number's out in front?
1.
This is going to be a slope of +1. So I'm going to go up on this side, up 1 and over 1, right? And I'm going to draw a line with arrows. So my slope is going to be +1, and also on the other side, -1. So please draw that line, or that V shape, I guess I should call it, if we are looking at ours. Okay. As you come in, I have rulers in the front. From now on, start grabbing something so you can make nice straight lines, because some of you are kind of doing lines that aren't very nice. So I want nice straight lines. So from now on, grab those. Okay, domain is what? What are all my x values that I could input? Can I put in fractions and decimals for x's? Remember, domain is your x value. Yeah. So when I think of my domain, it's going to be all reals. How about my range? The lowest is -3. So my range, where y is greater or equal to -3, for all real numbers. So let's go, please, I want you to try the next two. Try your vertex. What do we know about the slopes on all of them? It's all 1 and -1. All of them are slopes of 1 and -1. So start with your vertex. If it helps you to think of point slope form, do that. I'm going to give you just a minute. That second one. 0, -5. Slope of positive and -1. Domain should be all real numbers, right? Our domain is going to be all real numbers. What about my range this time? This time it's going to be all values that where y is greater or equal to -5 for the real numbers. So we use that kind of double R. Vertex. Someone want to tell me what we got for vertex, Emma? -2, 1. This is telling us move to the left 2, up 1. Same as if I was looking here, right? So I'm going to graph that. Does my V still go up? Yep. Should have been at -2, 1. Yeah, this isn't right. And I can't erase it now that I have it here. It should be right here. I put the wrong answer on our answer sheet. That's the way I had on my graph. So we're okay. So what's our domain? All real. What What's our range?
Y is
Greater or equal to, where?
1.
1. So you're always looking at the y coordinate for your range, right? Y coordinate gives us our range. Y coordinate as you look at that. So, in your homework tonight, back on page 57, use the parent function to divide you, write the equation. I might, if I were you, recommend writing point slope form. Why? Because that's what all of our absolute values look like, right? It's just that instead of the parentheses, it has an absolute value sign. So I might encourage you to think, oh, what was that? And I'm not going to write it. And then when you get down here, they ask you to write the equation. They just ask you to translate it. You don't have to graph any of these, right? Until you get to the bottom, and I believe it's number 11, okay? So what I want you to do, I want everyone to get to question 11 right now. So at the bottom of that bottom of your page. This is what I need you to tell me before you graph it. I need you to tell me right behind here, what is your vertex? Okay? So this is on the bottom of the page, and on the back page is this beautiful page of graph paper. When you make your graph paper, here's the one thing. I looked at some people's and oh my gosh, my head is cringing. I thought, what are you doing? So I can tell that my vertex here is 0, 3, right? That means don't make this graph so tiny, right? Like, you get this whole graph paper to do 6. Spread it out so you have 6 big graphs so that I can see your y and x axis. And then I have another one over here. And then you're going to spread these out so that when I go to graph number 11, and I put number 11 here, I'm going to write the equation right next to it. Y equals absolute value of x plus 3. So on the graph paper, if you turn your graph paper over, write number 11. Y equals absolute value of x plus 3. Put that equation and then graph it. So that when I look at number 12 over here, I am first going to see y equals, I'm going to see your equation. You're going to write this. Absolute value, not parentheses. And then you're going to graph. You're labeling your y and x axis as you make those. But now you should be able to make those. Should all of our v's be going up?
Yeah.
Yes, because we haven't talked about that. That comes tomorrow, where we're going to flip them reflective over the x-axis. Okay, that's going to happen tomorrow when we look at it. So, what was my vertex in number 11? Was 0, 3, right? And now I'm going to have a positive slope, and I'm going to have a negative slope. This is a piecewise function, right? There are still 2 pieces to that graph. It's just that we put it all in one. Okay? So keep checking those answers in the back as you are looking at them. Okay?